Hello, so for today's lesson, we are going to be learning about magnetic energy. As you can see here, we have the PowerPoint. Let's go ahead. So first off, I want to start by asking the class, what is magnetic energy? So who can tell me what magnetic energy means to you? Okay, we're going to go through the experiment and then we will find out. So for every good science experiment, you always want to start with a hypothesis or a question statement. Who remembers how to give me a hypothesis? Good. Okay, so what do we want to test? So here we're going to have two magnets, and then we will have a pile of paper clips. Okay, so we want to keep one in the freezer and we want to freeze it. So we want to see if the temperature of the magnet frozen in the room temperature magnet affects the number of paper clips that is attracted. So we want to see which magnet is going to be stronger. Okay, so raise your hand if you think the frozen magnet is going to have a stronger effect. Okay, raise your hand if you think the room temperature magnet will have a stronger effect. Okay. So my prediction is that I think the magnetic energy will weaken as the magnet freezes. As the magnet freezes. So that is my prediction. So I could very well be wrong, but we will find out. Okay, so what are we learning about? What are we trying to learn? What is this experiment teaching us? Okay, so this experiment is going to be about how temperature affects the magnetic strength. And we want to find out why it is important as well. So some key vocabulary words for this experiment obviously would be a magnet. And a magnet is a device that attracts iron and produces lines of force. Magnetic energy is an energy form of moving change carriers such as electrons. Okay? Now, what is an electron? An electron is an elementary particle with a negative charge. So we want to think of electrons as negative. Okay, and then a proton is a stable particle with positive charge. So proton, positive, electron, negative. So think proton, P, positive. Okay, that's one way to remember it. Okay, so let's go on. So how does this apply? So how would this apply? So what is some knowledge content that would be important for real life? Why would this be important in real life? Okay, good. So I put the knowledge of content is important because I believe science is a method of understanding. Not just necessarily magnetic energy, but science in all. I believe science, you have to experiment, you have to try to be able to learn. Okay, so it is important to understand the way a magnet works. All right, so for our experiment, we're going to need some variables. So we're going to need the manipulated variable, we're going to need the responding variable, and we're going to need the constant. Okay, so let's go over the manipulated variable. So the manipulated variable, what is going to stay the same would be the temperature of the magnet at room temperature and the temperature of the magnet frozen. So what's going to be changing is the number of paper clips attracted. Okay, and the constants is the size of the paper clips and the magnet. Okay, so as you can see here, they are two different magnets, but they're about the same size. So this one I had in the freezer, and this one's going to be room temperature. So the materials you need is magnets and paper clips. And then I have a pile of my magnets right here, or my paper clips. I have a pile of 15, and then I have my 2 magnets. So let's go over the procedures. So what we're gonna do for this experiment is we want to take the paper clips and we wanna just place them in a pile. I didn't put them in any particular order. I just set them in a grouped pile together. It's kind of hard for you to see, but you can see the pile of paper clips there. So we are going to see, with the frozen and the room temperature, in 10 attempts, how many each magnet picks up. Okay? So here's the data from my first experiment. Well, let's go ahead and, this is the frozen. So this is the first attempt. We have 5. Second attempt, 5 again. And then you can see as I'm doing this, I'm just putting them back in a pile. So this is the third attempt. Let's see. Oops, one fell. We have 5 again. So that's 3. The fourth attempt, 4. The fifth attempt, 6. That one picked up 6. Let's go to the 6th attempt. That picked up 5. 5 again. That's the 7th. Let's go to the 8th attempt. 6. Let's go to the 9th attempt. 5. And let's go to the last one. 5. Okay, so the majority, the average of the frozen magnet picked up about 5 paper clips each time. So let's go to the room temperature. Okay, so it looks like 4. 5. 4. It's the 3rd attempt, so let's go to the 4th attempt. 4. 5. 3. 4. 3. 4. A couple more. 3. And 4. Okay, so the average there, I would say, would be about 4. So you can definitely see that this was the experiment I did before. This was the frozen, so the median would be 5, the mode would be 5, and the range was 2. The room temperature magnet, the median was 5, mode was 5, and the range was 2. And then that's what it would look like in a bar graph. Okay, so the blue would be the frozen magnet, and the red would be the room temperature. You have your title up here in your bar graph, average number of paper clips attracted right here, and then you also have your X and Y axis. So you have a number of paper clips and the temperature. So the temperature is down at the bottom, the number of paper clips over here on the side. So that's what it would look like in bar graph form. Okay, so the results that I got for my previous science experiment, not the one done today, but the one that I did prior, the average number of paper clips when the magnet was frozen was 5.6, and then the average number of paper clips when the magnet was room temperature was 5.2. So my hypothesis was completely incorrect. So for those of you that raised your hand for the magnet being stronger frozen, you all are correct. So let's write a conclusion paragraph for this science experiment. So in conclusion, when the magnet was frozen, the magnetic energy was stronger than room temperature. So why do we think this happened? So let's talk about that for a second. Raise your hand if you can tell me why you think that happened. Okay, yeah, so it does have to do with the molecules. So the molecules in a magnet move slower, which allows a more concentrated magnetic field that strengthens the magnet. So when the magnet is frozen, it picks up more paper clips. So I thought that the room temperature magnet would pick up more paper clips. Usually in my mind, when something becomes frozen, I think of it as it doesn't work as well. In some cases, not all cases, I was unfamiliar with magnets, so this was actually a very good experiment for me to try and see, especially during like MRIs and all other businesses that use magnets, magnetic energy. It is a very good science experiment, I believe, for everyone that deals with magnets to do some sort of science experiment to understand why this works the way it does. So real world application, magnets are used more than people think. For example, like I said, MRIs in the medical field. So anyone that uses magnetic energy, I definitely would recommend using this experiment. And that is all.